there is a so when you're starting, right? Like when you're starting from scratch, and few people have the fortune of working on a greenfield project. But imagine you are tasked with this, with the goal of moving all this data into a centralized place because someone high up understood that there is it's an imperative to move it and put it somewhere else. We're not just copying it because we don't want to deal with the engineers or the devs. We are copying it because we need a truck and they have scooters. And now that we did that, where do we start? And I ask you this question because I have been one of the victims falling into the trap of this, not that. House, lake house, lake, a house on a lake close to a house. It's been a bit of a, it's been
Yeah,
a bit all over the place. So give me some clarity,
yeah,
please. What's going on?
yes. This was this exact problem is was largely the inspiration for the book, which was a vast majority of our customers at Chardio didn't know what to do in terms of taking those first steps towards better modeling their data. Um, in the past, there's kind of this tome in the space by Ralph Kimball, the Data Warehouse Toolkit. It's like hundreds of pages long, super dense, very specific about how to model data. Um, and a lot of the reasons why the book was written the way it was because of the constraints on the database. So again, it was kind of written pre-columnar data warehouses. So given all this new power, uh, our kind of 2 cents to add to the conversation, all of his stuff, still holds in a lot of ways. But what we wanted to add to the conversation was you have so much power now. You have tools like DBT, which make modeling the data much, much easier, much more accessible. And most of the issues that people have with data, at least initially, are just around kind of usability. So when engineers initially code field names and populate it with data, or when you're pulling data from all these applications using a tool like Fivetran, the field names aren't necessarily written for you to do analytics on. So you'll get kind of sometimes these archaic looking things or cryptic codings, like a lot of times fields like license type or user type will be in numbers. So there'll be a 1, 2, 3, and a 4. I don't know what those are as someone doing the analytics. And so there's some simple things you can do with modeling where you can just make the data readable. And that honestly gets you pretty far, just in terms of being able to unlock the data, making it more accessible to the org. Then there's, if you really want to constrain how the data is analyzed, there's some pretty typical stuff around, star schemas and wide tables and that sort of thing. It's interesting that nowadays seemingly wide tables are as performant. That's like kind of a controversial, debatable thing. But Fivetran
Sorry,
put out that
what was it?
benchmark.
What less performing?
Um, so in the past, like star schema was kind of like this is the golden standard, super performant. Fivetran a couple years ago showed that nowadays, again with these columnar databases, that just turning it into a wide table,
Yes, yes, yes.
it was essentially equally as performant. So again, the reasons to do star schema are pretty much all the performance reasons are gone. And now it's just like, if that's how you want to set it up for your company and that helps your company process information, great. But yeah, the point we were trying to make was you can just clean up the data, just make it readable. And that's kind of the 80-20 benefit initially.
Yeah.
and then like, you can kind of approach it with just design thinking and, what do my end users, my end analysts need? What would be useful for them to have in here? What additional columns might be beneficial? And so we just wanted to make it like a more, to show you that the first step is something that with just a little bit of intuition and a feedback loop, you can make progress on.
Yeah. And so in a sense, we will dive perhaps into the star versus white column debate later, because I think it's pretty interesting. But just stay on the surface for a little longer. Like the choice of a lake is not sort of the end of the game, right? Like once you collate all the data into a place, then you have to, as you said, refine it and add to it. And so in your book, you make the distinction between the lake, the warehouse, and the mart. And there's been a lot of confusion around the term data warehousing, because I believe historically it started out in the context of a database that is specifically designed to power a dashboard or some sort of analytical need. And so people have this feeling of this stiffness to it, something that you can't change, that is at the end of the value chain, almost the end of the pipeline. But
Yeah.
is it true with the modern data stack, or what's the difference? What's this big deal between the difference between lakes, warehouses, and marts?
Yeah, and I mean, perhaps the other term to bring in that kind of came up in the middle of us writing the book, it didn't get added, is like LakeHouse, which Databricks is pushing pretty hard. Um, I think in general there aren't super hard boundaries. It is more conceptual. So the lake is, and all of it's built on the same technology, or at least can be. So, if you have Redshift or BigQuery set up, you replicate your production database into there. You use, again, Fivetran or Stitch to pull in all of your other various data from across your sources into there. And okay, all the data is now in Redshift or BigQuery. That is the data lake. Just the getting all of your sources in one place. Now, what makes DBT powerful and why it's so exciting is not only does it let you, clean those data, those sets of data up individually, and even join that data together with SQL code. It's that you can then do secondary modeling on top of the table you just made, and so on and so on. So you can create layers of modeling, which is super powerful. So again, when I was talking about, if you just do the cleanup, you've essentially built layer one of the data warehouse, which is kind of the any amount of modeling of the lake that makes it more usable. So if you just do the cleanup, you've already started to build your data warehouse. And then if you, from there, it's like, oh, well, maybe I want to, combine like user profiles across different tools, and you can make like a master user table, or whatever your business needs
Logic.
are.
Yeah.
Right. And you can kind of build out these layers. The term is directed acyclic graph, or DAG. And that's what makes DBT so powerful. You can kind of build your data warehouse in layers. And then so you kind of make this new, cleaned up, tuned to your business version of the data. So that's kind of your data warehouse. And then from there, the data marts are, again, it's a little bit of a blurry line, but it's essentially doing additional modeling and oftentimes scoping down the amount of data available in terms of across the schema for a specific use case. So if you want to make a data mart for marketing, maybe you do some extra calculations about ROAS or some other metric that they care about, and then you don't have all these other tables related to HR or whatever, and so you can kind of give them a space to query from that is tailored to them, and fewer places to kind of get lost. Those are kind of the traditional distinctions. Again, the lake house is essentially kind of trying to argue for, some space in between lake and warehouse, obviously with the name. And I would talk with, somebody from Databricks to really give you the lowdown there. But again, it's similar in aspiration, which is, can we deliver more with doing kind of less on the modeling side?
Yeah, and you mentioned directed cyclic graphs. For those that never heard of it, there's nothing. I know it sounds like a medicine, or it might feel like a weird term, but there are three elements, three words to that. Directed, it means has that direction. Things flow from left to right, or depending on the convention, from one side to the other. Acyclic means that you don't have cycles into it, so you don't want to end up in a way where the output feeds back into the input and you don't know whether you're looking at an output or an input anymore, because that's the realm of dynamic systems. And for the folks that have a background in physics, you know how complicated that is. So you don't want cycles. So directed, acyclic, and then graph, because it's a graph.